Okay, so now let's talk about another divide and conquer algorithm in merge sort. So what you may have just encountered so far were O of n squared algorithms for sorting, which are the bubble sort, insertion sort, and I think selection sort. So now let's apply the divide and conquer approach to our sorting problem. So similarly to binary search, given our initial list that we want to sort, we first partition it into two parts and then try to sort the partitions in another way. Or we can sort those two partitions using merge sort. So let's focus on this partition here. We partition it to two more uh, two more subarrays, and then we sort these subarrays. And then to sort these, we apply merge sort, wherein we split them and then sort them. Now, I can go on and on. So I think you see the point why recursion is a very useful and straightforward way to implement divide and conquer algorithms. But going back, when we already have two sorted lists, we can easily merge them to a single sorted list through the merge algorithm. So uh, a quick summary over or maybe a good snapshot of the merging algorithm is in this picture. So when we have two sorted sub partitions here at the top, one partition per color, uh, we choose whichever element has the lowest value for each partition. So clicking this picture will actually take you to a video that would go a little more in depth on merge sort, but I'm gonna show you the same animation over here very, very quickly. So the splitting or the partitioning of the list continues until we have one element per partition, because in that base case, a one element list is already sorted. So at the start, we merge the partitions that are adjacent to each other, and then we merge them. And then when the subpartitions are sorted, we merge them with the other subpartitions. So hopefully you can understand it through this animation. And let's just let it finish. So we can most appreciate the merge algorithm in this final run, wherein we have two arrays that are sorted and then are combined together, so merge. So that actually highlights the three parts of our divide and conquer algorithm: the division, the conquering, and then merging. So that is merge sort. Now I actually have here an implementation of merge sort. So this is the function for merge sort, which just calls merge sort. So this is what we call a helper function when we make recursive functions or recursive algorithms. So it makes us sort of remove the other arguments that we need to pass in the recursive call, such as the start and end arguments. So we let the helper function determine that for us. And we can also add here some input validation in order to check if maybe the certain input might cause a stack overflow when we pass it to a recursive function. So this helper function handles that. So looking at merge sort, so we first look for the midpoint. We merge sort the lower partition, and then we merge sort the upper partition. And then we merge those partitions together. So it looks kind of easy, right? So what's actually most complex or most uh, what you most need to think about here is the merge algorithm, which inserts the elements of the partitions into a single temporary list and then appends them to that list. So yeah, so after merging the partitions, it returns it back to the original array. And now the sorted partitions are now merged into a sorted array. So do we need to prove the correctness of this algorithm? Maybe not here, maybe in the quiz. Maybe. So here, so when we call merge sort, so our list is initially unsorted. When we call merge sort, it results to a sorted list. So basically, this is what I talked about when we went through the code. So yeah, so that's merge sort. So for the next videos, let's analyze it.